Let's talk about protein analysis, which include two techniques called chromatography and electrophoresis. So protein analysis is used for two different purposes. So you can have a mixture of protein and you try to separate them into protein A, B, C. Or alternatively, you can have a protein already and you're trying to separate the different amino acid. Well, in that case, you want to take your protein and you break that protein down into amino acid using hydrolysis reaction. Acid here. Alright, so once you have either a bunch of different protein, a bunch of different amino acid, the separation process is similar, and there are two methods. First method is called chromatography, and second method is electrophoresis. Alright, so chromatography, you're putting some protein on a piece of paper and then let it run like this.
I like to eat each time I look into your eyes. I see some pretty colors. Very nice. I wouldn't mind paying any price. I've got charm over you. I say go honeydew. You are my ice kacang in this tropical heat. You are my favorite dessert. So inviting, so sweet.
So this method is separating the amino acid of the protein based on their affinities for the two phases, the stationary and the mobile phase. Piece of paper, you have put the protein on the bunch of amino acid here at the origin, and then as you can see in the video, it ran up here. Okay. So now protein are clear, so you will have to stain them with locating reagent so you can see it. So after you stain it, say you're going to see a blue protein here, a red protein here. Okay, the solvent or the waterfront up here. The position for each amino acid will be measured by something called an RF value, which is retention factor. So retention factor is equal to the distance that the amino acid move divide by the distance that the solvent move. So for example, we look at our blue amino acid here. Let's just call it amino acid A. So this amino acid, the distance that is moved is this small distance A. So the RF value for A is small a divided by the distance that the solvent, the water, see this yellow water mark? Let's call it X. So the RF value for the A protein is A over X. And that number, so when you run this gel and you get an RF value, you can compare that RF value, let's say for protein A, for amino acid A, or protein A, doesn't matter, value, and then you compare with some known number. So you would know, oh yeah, A is amino acid glycine, for example. The second method is electrophoresis. It is similar to chromatography, that is used to separate the amino acid or the protein, but the difference is that the separating is based on the movement in the electric field. As we know that different amino acid or different proteins have different charges depending on their pH. So similar to the paper, but instead you are going to have a gel. Sometimes you hear gel electrophoresis. And instead of having a dot, you are going to have a well in the middle of the gel where you can put your protein or your amino acid mixture in here. Okay, you put in this well, and then instead of using the water to move this protein or amino acid to the two sides, you are going to use a voltage, a negative and a positive charge on both ends of the gel. So if you are having a protein that, let's say, is negatively charged, this protein or amino acid, same deal, is going to move toward the positive charge, and then you're going to see it over here. And vice versa. If you have a positive charged amino acid, it's going to be moving toward the negative because opposite attract. And similar to chromatography, you also will need the locating agent, otherwise you won't be able to see it. And then similar to chromatography, position at which these amino acids move one way or another can be compared to a known value, and then you will figure out which protein or amino acid it is.